Welcome dear students, I am Mr. Abhijit. Welcome to my channel Chemistry Learners. So in this lecture we are going to see effective nuclear charge, that is Z effective. What is this Z effective? How this Z effective is calculated and what is the trend in effective nuclear charge in the periodic table. So we will see in details the calculation part, how this Z effective is calculated on the basis of Slater's rule. So let us start with this. Effective nuclear charge is the net positive charge that is experienced by an electron in the atom. Okay, so it is given by the formula, that is Z effective is equal to Z minus sigma, or sometimes this sigma is given as S. Z is nothing but the atomic number of the element, or you can say it is also called as proton number. Then the sigma is called as the shielding constant. So this shielding constant is also the constant which is given by the Slater's rule. So we'll see what is shielding constant. This represents the degree to which the other electrons in the atom shield the electron from the nucleus. On the basis of Slater's rule, the Slater provided some of the estimated constants for the particular levels. So we'll see that particular levels, and according to this, the Slater rule contribution is given for different levels. So if you see the level means n is nothing but the principal quantum number. So this principal quantum number for s, p, d and f orbital, that may be same, but if you see the contribution for the particular n level is 0.35. If the level is n minus 1, then it is 0.85, and n minus 2 and lower levels if you consider, it is 1 per electron. Now what is this n minus 1 and n minus 2? That we will see in the example. Now consider, if I have the electron, suppose sodium. So atomic number of sodium is 11. If I write the electronic configuration, 1s2, 2s2, 2p6, 3s1. So if you consider the n number, now this is the n shell in which last electron is placed. This is the n minus 1 shell, and this is n minus 2 shell. Now understand, if you consider n is 3, if I want to calculate the Z effective for the 3s1, for this 3s1, the n value is this. Understand? Now we will see the example. Calculate Z effective for 3p electron in phosphorus. Now see here, I want to calculate the Z effective for 3p electron in the phosphorus atom. So first of all, I need to write the atomic number. Atomic number is 15. Then I need to write the electronic configuration. So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p3. This is n shell. So I want to calculate this for 3p electrons. So 3p electron is here. Okay. So for this third shell, it is n shell. For this second shell or second orbit, it is n minus 1, and for this the n minus 2 orbit is the 1s2. Now I am calculating the Z effective for 3p electron. Now if you consider the Slater rule, in previous slide I have given the Slater contribution. If you remember it, Slater contribution for n, it is 0.35, for n minus 1 it is 0.85, and for n minus 2 and onwards it is 1 per electron. Understand? Now I want to calculate it for the 3p electron. So 3p, 3 electrons are there. So if you consider the n shell, for n there are how many electrons? Now I am calculating it for only one electron. So 2 electrons from P are remaining. So there are 2 electrons in P and 2 electrons in S. So there are total 4 electrons in N orbit. So it is 4 into 0.35. It comes around 1.35. Understand? Now I am calculating for N minus 1 shell. So this is N minus 1 shell. So how many electrons are in N minus 1 shell? In N minus 1 there are 6 electrons for P and 2 electrons for S orbital. So total there are 8 electrons. That's why 8 multiplied by, what is this? N minus 1. That's, I need to put this value, that is 0.85. So this is 0.85. So it comes around 6.8. Understand? Now I want to calculate it for 1s2. For 1s2 it is N minus 2 shell. So it is N minus 2 shell. So 1s2 means there are only 2 electrons and N minus 2 level, it contributes 1 per electron. That's why it is 2. If you calculate it, so the calculation of this, that is 1.35 plus 6.8 plus 2, it comes around 10.20. Okay. So this calculation is, I think, 1.40. Okay. It is 10.20, and if you put this value of S, so this is S or sigma you can say, that's why the formula is Z effective is equal to Z minus sigma. Z, your value of Z is 15 minus 10.20, it is 4.80. That's why Z effective for 3p electron in phosphorus is 4.80. So in this way, this calculation can be done. So if you do the calculation for another element, say we will see the another example. Like suppose I have given here, so 3s electron in sodium. So what is the atomic number of sodium? It is 11. The electronic configuration is 1s2, 2s2, 2p6, 3s1. So I want to calculate this for 3s1. So for this, please remember here, for this 3s1, it is n value, it is n minus 1, it is n minus 2. So if you calculate this, so for this, only one electron is present in the 3s orbital. That's why it contributes 0. Because there is no any other electron which shows effect on the other electron. So there is only one electron. That's why the contribution is 0. Now we'll move to the next part, that is n minus 1. So here there are total 8 electrons. 8 into, what is the contribution in n minus 1 shell? It is 0.85. That's why 0.85. And it comes around 6.80. Now here there are n minus 2, means 2 electrons are there. It's 2 into 1 electron, it is 2. So if you do the calculation of all these three things, you will get 8.80. So this is the value of sigma. Now if you put the value in the formula, Z effective is equal to Z minus sigma, it is 11 minus 8.80, and the final answer is the 2.20. This is the Z effective for 3s electron in the sodium. Understand? Now we will see for 2p electron in the carbon. Carbon atomic number is 6 and the electronic configuration is 1s2, 2s2, 2p2. I want to calculate it for 2p electron. So there are 2p2 electrons. So for 1 electron I want to calculate it. So that's why this is the n level for this. So total the second orbit is the n orbit, and here it is n minus 1 orbit only. So in n orbit there are total, except the one electron, there are total now, these are the 4 electrons, okay, but I want to calculate it for only 3 electrons. So 3 into 0.35, it comes around 1.05. Okay, now there are 2 electrons in n minus 1 shell. So 2 electrons means 2 into contribution is 0.85, 2 into 0.85. So it is 1.7. Understand? Now if I calculate the sigma, what is the value for sigma? 1.05 plus 1.7. So it is 2.75. This is the value for sigma. Now Z effective is equal to Z minus sigma. Z is the 6 minus 2.75. So the calculation is 3.25. So this is the Z effective for 2p electron in the carbon. Similarly, you can calculate this for 3p electron in sulfur. So please calculate it and post your answer in the chat section. In this way, we have seen how to calculate the Z effective for different electrons which are present in different orbit and orbitals. Now we will see the trend in effective nuclear charge. Across the period, effective nuclear charge increases because more protons get added to the nucleus. As you go left to right in the periodic table, what happens? Electrons are added into the same shell and hence the size is decreases. Therefore, the effective nuclear charge increases. And if you go down, means top to bottom in the periodic table, it is slightly increases because each time if you go to the next element from top to bottom, new shell is added, and hence if there is addition of new shell, the size is increases, and hence there is a slight increase in the Z effective of the particular element. Okay, so with this we have seen how to calculate the Z effective, what is Z effective and what is the trend across the period and down the groups in the periodic table. We stop here. For such important and informative videos, please subscribe to my channel Chemistry Learners. Thank you.